The pollutants, as I would see it, is the unspent fuel that would leave the stack. So if the house is satisfied with heat, the combustion chamber is shut down. The damper is closed off so that no more air comes through to continue the combustion. So the wood can actually smolder, in which case you're just spewing out unused fuel out the stack. We literally are running this stove. It's almost open damper all the time, which means that the fire is running hot all the time, just to try to keep up with the demand of the house. We have to feed wood on a daily basis. Actually, my wife feeds it about 3 times a day.
We're trying to evaluate this new generation of European technology for pellet boilers that was developed in Austria and is now being manufactured in Troy, New York. So it provides an alternative heating system which will very efficiently burn pellets and provide hot water heating. The pellets are stored on the other side of the wall here, and they get augered up into the system from behind. What we have here is the actual boiler. This is a 25 kilowatt boiler. It uses what's called multi-stage combustion. So what you're doing then is starting off by heating the pellets at a relatively low temperature so they break down into gases. The gases then burn, and that way you get more of the ash retained within the unit rather than going up the stack, and you get much more efficient utilization of the fuel. So you're getting much higher total energy output from burning the pellets, and then it has a very high efficiency heat exchanger, which allows you then to take the hot gas and move that energy into the hot water that then gets transported into the hot water tanks.
Leaving the container, you can see in the back here some piping. That piping will very simply exit the container. In this particular application, the piping will come across this small walkway here. Those pipes will all be sealed and insulated as time goes on. And then you'll notice on the inside of our building here, the piping comes through, it wraps around the inside of the structure, and then it will tie into the piping that goes into the house. So what you see down in the small hole there is the supply and return piping that feeds the inside of the house and the in-floor heating system in this particular case.
We're finding that it's extremely expensive. You know, we have a very old home built in the 1800s, and you know, we lack insulation. We lose heat easily, and with that, you know, comes more fuel oil, and it's expensive. You know, the cost is variable. It's forever changing. We never know what to expect, and you know, it's often a surprise as to what we're going to pay. You know, in addition, it's dirty. You know, the upkeep is not, it's not fun by any means.
Couple of differences here. Obviously, the pellet storage is outside, and that avoids some other problems because pellets do off-gas carbon monoxide, and to make sure that we're perfectly safe, we're putting the pellet storage outside. And it also makes for very easy delivery because then they can just pneumatically deliver the pellets up into the bin. The pellets will eventually get augered down into, it's the same boiler as we saw in the container, but now you see there's only one water tank because this is a smaller total heat load, and so we don't need to heat as much water as we did in the other installation. And we're running it in parallel with the existing oil-fired boiler, which will be set at a temperature below that produced by the pellet boiler, because then as long as the things are working fine, the house will be heated by the pellet boiler. If for some reason there's a problem with the pellet boiler, then the oil boiler will turn on, and they'll never lose heat in the house.
There's a great change going on now with wood heating. There is a wide variety of technologies, a wide variety of performance, and Clarkson University is performing an independent third-party evaluation of that performance We want to know about thermal efficiency, annual fuel use efficiency, representative of the good performance as well as the times when it's more difficult for the boiler to meet the heating load challenge. We want to know about the emissions. And with these boilers, the laboratory studies have shown that they can reduce emissions from older technologies by 99% or more, and it can also quadruple efficiency. This study will look at it under a variety of weather conditions, a variety of building load heating demands, and really look at it in those challenging moments as well as its best moments. And what we do and we live for is bringing more efficient technologies into the market.